Welcome back. In this lesson, we are going to explore how to use retrieve and generate API with Python. These APIs allow us to pull information directly from the knowledge base we created in a previous video and then use that data to generate meaningful responses. We will start with the Retrieve API. This is used when you simply want to fetch relevant document or data from your knowledge base. Think of it as a search function. It finds the most relevant piece of information based on your query. Next, we will move on to the Retrieve and Generate API. This one takes things a step further. Not only does it retrieve the data, but it also uses that information to generate a natural language answer. This is especially useful when you want to conversational response instead of raw document. The Retrieve API is designed to fetch relevant information directly from your knowledge base. When a user sends a query, Bedrock does not generate a response. It simply searches the knowledge base and returns the most relevant chunk of data. Think of it as a powerful search engine for your custom knowledge base. You provide a prompt, Bedrock look into the store document and it gives you back the matching piece of text. This is especially useful when you want raw data or supporting documents rather than a natural language answer. For example, if you are building an application where the user need to see the original source material, the Retrieve API is the right choice. In Python, you will send the query to Bedrock, specify the knowledge base, and then capture the written chunks. This chunk can be displayed directly to the user or passed into the other process to further handling. Let's implement the Retrieve API using Python. First, we start with the line import Boto3. This import the Boto3 library, which is the official AWS SDK for Python. It allows developer to interact with AWS services directly from their code. Next, we create a client. The word Bedrock Agent Runtime tells Boto3 which AWS service we want to connect to. In this case, it's a Bedrock Agent Runtime, the service that let you run AI agent powered by foundation models. The region name US East 1 specify the AWS region where your resources are located. Regions matter because services and data are tied to the specific geographical area. So in just two lines of code, you have set up Python program that can talk to AWS Bedrock. From here, you can send a request to run agent process inputs. Now that you have set up our Bedrock agent runtime client, let's look at how to retrieve information from knowledge base. Here is the code. In the previous video, we have already implemented a knowledge base. From that step, we will have received a unique knowledge base ID. This ID is important because it tells AWS Bedrock which knowledge base your application should connect to. Think of it as an address of your knowledge base. Without it, the system would not know where to look the information. Now in your code, you can simply add this knowledge base ID inside the configuration. By including this ID, you are linking your Python client directly to the knowledge base you created earlier. That means when you run retrieve and generate query, the system will pull information from specific knowledge base rather than searching something else. Retrieve query text. This is actual question we are asking. In this case, we want to know the title of report. In retrieval configuration, fine-tune how the search works. Here we are using vector search configuration with number of results set to 3. That means the system will return 3 most relevant match based on the semantic similarity. The result is stored in variable response. From there, you can inspect the output, extract the relevant field, and present in the answer to your user. We have just run our retrieval query against the knowledge base, and here is what the response looked like. First, notice the response metadata. This section confirms that the request was successful. The HTTP status code is 200, which means the query completed without errors. You will also see request ID, which is useful for debugging or tracking logs. Next, we have a retrieval results. This is a heart of response. Each item here represents a chunk of text that the system found relevant to your query. Let's look at the first result. The content field show text from the document. In this case, it's begin with the 2025 report, the status of enterprise AI that tell us title of report we are looking about asking about. The location field point to where the content lives. Here it's stored in Amazon S3 with URI link of original PDF files. This is important because it let us trace back to the source document. The metadata section add more context. For example, it tells us the page number in the PDF, the chunk ID, and the data source side. These details help us understand exactly where the retriever text come from. Finally, notice the score. This is relevance score. The highest score, the more closely the text match our query. In this case, the top result has the highest score, which is why it contains the report title we are looking for. Now let's look at the retrieve and generate API. This API combines two powerful steps into one. First, it retrieves the most relevant chunk of information from your knowledge base, just like the retrieve API, but then it goes further. It uses that data to generate a natural language response. Here is how it's work. The user sent a prompt into Bedrock. Bedrock search the knowledge base and pull out the most relevant piece of information. Instead of returning raw chunk, Bedrock pass those result into a language model. The language model then generate a clear conversational answer that's grounded in the retrieved data. This makes the retrieve and generate API perfect for building chatbot QA system or any application where you want to use to get polished response rather than just source text. In Python, you will send the query, specify the knowledge base, and Bedrock will handle both retrieval and generation in one call. The output you receive is ready to use answer backed by the knowledge base you created earlier. Now let's implement the retrieve and generate API using Python. The first two lines of code are exactly the same as when we used the retrieve API. We import Boto3 and create a Bedrock client. From there, instead of calling retrieve, we call retrieve and generate API. Input text is the natural language question we are asking. Instead of just pulling raw chunk of text, we want the system to give a synthesized answer. Retrieve and generate configuration define how the process works. The type is set to knowledge base, which means we are querying a knowledge base rather than just document or other sources. Inside knowledge base configuration, we have defined knowledge base ID and model ARN. Model ARN tells us Bedrock which foundation model to use for generating the answer. In this case, it's Amazon Nova Micro model. In vector search configuration, we have set number of result 3, which means the system will retrieve the 3 most relevant chunk before generating the answer. The result is stored in a retrieve generate response. Unlike plain text, this response does not just give your raw text snippet. Instead, the model read through snippet, understand the context, and produce the clear natural language answer for your question. We have just run the retrieve and generate call, and here what's the response tell us. First, notice the response metadata. This section confirm that the request was successful with HTTP SSL score of 200. That means the query completed without errors. Let's look at the citation. This shows us exactly which piece of text from the knowledge base were used to support the generate answer. Each citation includes the generated response part, which is the portion of answer created by the model, the retrieve reference, which point back to the original source document in Amazon S3. This ensures transparency. You can trace the generated answer back to the evidence. Now, the most important part is the output. Here, the model has synthesized the information into clear response. The title of the report mentioned in the search result is the State of Enterprise AI 2025 report. This report discusses various aspects of enterprise AI adoption, including industry trends, growth rates, and impact of AI on financial performance and organization outcomes. This is a key difference between plain retrieval and retrieve and generate. Instead of just giving us raw text chunk, the system uses a foundation model to read those chunk, understand the context, and produce a polished, human-friendly answer. Finally, notice the session ID. This helps track the conversation state so multiple queries can be linked together in one session. If your data is stored in chunk format, whether as plain text or JSON, you can apply a meta filter to refine the results. A meta filter works by mapping field from your JSON file and apply condition to filter out only the data you need. For example, you might filter by category, language, or creation date. This ensures that when you run a retrieval query, Bedrock only returns chunks that match those specific criteria. Adding a meta filter to your code is straightforward. You simply include the filter configuration alongside your retrieval setting. By doing this, you gain precise control over which chunks are returned, making your search result more accurate and context aware. And that's it. We have now successfully implemented both the Retrieve API and Retrieve and Generate API using Python. With these two approaches, you can either fetch raw data chunk directly from your knowledge base or go a step further and generate conversational answer grounded in that data. Thanks for watching this video and I will see you in next one.